Hello and welcome everyone. This is the Ethereum Engineering Group Meetup. I'm Peter Robinson, and today we've got Franck Royer from Status, who's going to tell us all about Waku. So Franck, why don't you introduce yourself, please?
Hi everyone, and thanks Peter for having me. So yes, I'm Franck. I am currently based in Sydney, Australia, and I work at Status. I'm the team lead of the DappConnect team, and today I will tell you a bit more about what is DappConnect and what is Waku. I've been working the ecosystem since 2018, and only joined Status in March this year. I'm very excited to work on Waku and DappConnect. Yeah, thank you. Let's start it.
Yeah, sure. Please share your slide.
All right. Okay. Can everyone see my slides?
Yeah.
Awesome. All right. So so today we are going to talk about DappConnect and how Dapp developers can use it to decentralize their communications using Waku. So let's have a look at the agenda. So first, I will introduce Waku, what it is, and then on top of that, I will talk about DappConnect. Then we see some use cases so that we have a bit more of a concrete idea what we can do with it. And then finally, we look at some code. So the first three sections are good for everyone, and the fourth section will be more for developers. So Waku V2, or what is Waku V2? A good way to talk about Waku is to look at its inception and why it was created. So originally, when Web3 was created, there was three protocols: Whisper for communications, Swarm for storage, and then Ethereum that we all know for contract. Status very early on created a chat app which is fully decentralized. And when they started building the app, they tried to use Whisper. However, Status being a mobile phone app has some issues with Whisper. For example, Whisper uses proof of work for spam protection. So you can imagine that when you have a phone on the network and a server on the network, and proof of work start to be difficult to manage because you need to use a lot of CPU on the phone to be able to send you messages, for example. And there was also some scalability issues. So Status created a Waku mod or Waku V1, which is built on top of Whisper, that solves this problem and allows a chat app today. So today, Status app uses Waku V1, and you have a free decentralized chat app that is able to work on desktop and mobile phones. Yeah. So both Whisper and Waku V1 use Dev P2P, which is the same technology used by Ethereum 1 for communication and sending transactions. So learning from Waku V1, we created Waku V2, which is a brand new tech stack. Waku V2 uses P2P and has a new set of protocols that are fully adapted for mobile phone environment. So the idea is really try Whisper, didn't work, made Waku V1 on top of Whisper, and then realized, okay, let's start from scratch and have a brand new protocol, which is Waku V2. So let's talk about what is Waku V2's goal. What's important to notice here, and the reason why I'm here, is that Status' aim is to allow everyone to use Waku V2. So it's not creating the protocol and just using for the chat app. Is creating the protocol, but also trying to promote the infrastructure and promote DappConnect for anyone to be able to use this network. So Waku V2's goal is to provide an infrastructure and standard for decentralized off-chain private communications to the Ethereum ecosystem, while considering the limitations of restricted resource environments. So it's very mouthful here, quite a lot of things I just said. So let's just go in a bit more detail and break down this statement. So when I talk about infrastructure, it's very similar to Ethereum in the way that when you build Ethereum DApp, you don't have to run an Ethereum node. Okay, so you can run an Ethereum node if you want, but when you're building a DApp, when you're using Ethereum, you don't have to run your own node. Okay, you don't have to worry about spinning off some nodes, running some servers, and things like that. So Waku aims to provide the same thing in the ways that if you want to use Waku, you can just use it without having to set up an infrastructure for it. But it is an open system. So if you do want to run your own node, then you're welcome to do so. All the code is open source, the specs are open, so everything is free to access. A standard, so more in the sense of a de facto standard. The idea is that by having a common ground to do communications, then it's easier on one hand to reuse Waku from one project to the other, or maybe having some interoperability if, let's say, you want a DApp and wallet to have some communication happening, or maybe between two different dApps. So having this common ground, this common language to do communication will allow better interactivity and faster development, in short. Decentralized. So decentralization is a technical property that brings you a lot of functional properties as we know them. So having a decentralized system, the same way than for Ethereum, so I'm sure you're all very familiar with it, allows you to have no bottleneck, better censorship resistance, trying to avoid discrimination, having avoiding single point of failures, maybe reducing risk, infrastructure risk, and legal risk. So all these properties that a decentralized product brings you have it with Waku. Off-chain, so just wanted to highlight here that Waku is not about using the Ethereum blockchain to send messages. It is a separate network. So it means that you can expect that when you send or receive messages, you don't have to pay a gas fee. Waku is very modular, so there is a lot of different protocols. And one of the spam protection protocol we're working on do use smart contracts on the blockchain to basically limit spam. But it's very modular, so it will be really up to each DApp builder to decide what protocols they want or don't want to use. Private, so Waku keeps in mind that some dApps need some privacy guarantees, whether it's pseudonymity or maybe end-to-end encryption and things like that. So while you don't have to encrypt all the messages, there will be a very easy way to do so. And so as part of the protocol, there is a space for symmetric encryption, asymmetric encryption, signatures, extra. Communication, so sending and receiving messages. So it is not a competitor to IPFS, for example. It is not about solving decentralized storage. It is about solving decentralized communication. So whenever you want to send or receive messages in a near instant manner, then Waku could help you there. So Status is has a Web3 wallet, and it is an Ethereum project and company. So we are targeting the Ethereum ecosystem. We are, for example, in terms of cryptography choices, we made similar choices to the one made in the Ethereum ecosystem, so that interoperability is easy. And we also provide examples and API to easily use Waku with a Web3 wallet, for example. But at the end of the day, it is an open system with open code and open specification. So any other blockchain project, and we do actually have some other blockchain projects who are keen to use Waku, could do so, or even projects that which are not related to blockchain at all. Okay, our target is the Ethereum ecosystem, but it is an open network, so anyone can join and participate. And finally, so I did mention that originally the idea was to have it work. I mean, it is designed to work on mobile phone. A mobile phone is a restricted environment in the way that you may not have connectivity all the time. You may have data plans that limit how much data you can send and receive, limited battery or CPU, but it also includes a browser environment. So in a browser environment, you may not have as much storage. You may not be able to access TCP stack, things like that. So Waku's protocol, Waku is really designed for this limited environment, which allows DApp developers, whether they're building a web DApp or whether they want to do a mobile app or a desktop app or anything in between, they can use Waku and they have the protocol fitting their need. Okay, so so far I've been talking about very abstract things. So now let's go a bit more. What do we have concretely? What's Waku? So we have a number of available implementations. So first one is NIM Waku. For those who don't know, NIM is a functional language in between, like similar to Python and Rust. So this NIM Waku library allows you to run an adaptive node in the way that it's very modular. So when you run a node, you can decide what protocol you want to enable. It is a reference implementation for all the protocols. And it can be used as a backend. For example, if you have a more complex system, then you could still run some node yourself and you would run some NIM Waku nodes. You can use it as a native library. So if you're building a desktop app, for example, or you can just run the node by itself as a way to get some as an incentivized node. So you can just run a node by itself, the same way you would run an Ethereum node by itself. Then we have JS Waku. So that's the JavaScript library written in TypeScript. So you have types available. And that is what allows dApps, web wallets, web apps to access Waku network. And we go more in details on JS Waku as part of the DappConnect section. And finally, worth mentioning is that we also have a Go implementation. And that's the implementation we are using to migrate the status chat app from Waku v1 to Waku v2. Because the status chat app uses Go as a backend. All right, so why would you want to use Waku for DApp? So Waku really solves the communication problem. So whether you want to have user-to-user communications in your DApp, or maybe operator-to-user, meaning you want to have some, your DAO, and you want to be able to notify your users that the bot is starting. Any kind of communication can be solved or can be done using Waku. It removes the needs of infrastructure. As I mentioned, the idea is that the network is available and you don't have to run your own node to participate to it, to use Waku, but you can if you want to. And today, if you want to have some sort of communication, the easiest way is to have a centralized server, but then your DApp is not decentralized anymore. So without having to basically solve complex problem which comes with decentralization, you can still have decentralized communication. With DappConnect, we aim to bring you an out-of-the-box solution, so something very easy to use. And again, the idea is that if you don't have to, so the same way that when you use Ethereum or when you bid on Ethereum, you don't have to solve Ethereum scalability issue by yourself. You can participate, you can participate to the effort to solve scalability issue, for example, but you don't have to do it to use it. And the same for Waku. If you want to use Waku and do communications in a decentralized manner for your DApp, then you can just use Waku. And if you want, you can join the effort to also do the research and help building Waku to make it, to extend it. All right, so Waku is really the protocol layer. And what we created is DappConnect, which is something just easier to grasp for developers. So DappConnect is just a set of documentations and libraries to allow you to add communication features to your Dapp. So Waku is the protocol, and if you're a researcher or you're really interested into the underlying protocol and how things work, then you can go and jump in Waku. But if you are a Dapp developer and you just want to add communication to your Dapp, then DappConnect is your entry point. So it contains JavaScript, TypeScript library. JS Waku is part of DappConnect. And we have code examples. We are writing tutorials, having some explanation videos, having use case studies, etc. So the idea is that DappConnect is your entry point. It's like your Web3 API. It is what you're going to look at when you want to add Waku to your project. So today, what do we have available in DappConnect? So we have the JS Waku library allows you to receive messages. So I mentioned two protocols to receive messages. So we have Relay. So Relay is a peer-to-peer gossip protocol. So we are connected to several peers. They are your neighbors. And if they receive messages, then they forward it to you. And so that's really for near instant messages. You receive messages via Relay. And that you can see can be an issue if you're on mobile phone, for example. Maybe you just lose connection, so you're not receiving messages because you're not connected. And once you reconnect, your peers are not going to send you all messages, so you may have missed messages. That's why we have Store. So Store protocol, you can query a node that supports Store and get some archive messages, so like older messages. So the idea is that in the network, people can use Waku to run Store nodes. They will save any messages they see on the network via Relay. And then on a mobile phone, as a DApp developer, you can ensure that if you resume connectivity, then do a query to a Store node to receive messages that you may have missed. So that's why. So that's one of the aspects. That's one of the aspects of having Waku built for restricted environment, having these protocols available that take into account, okay, what happens if I'm not connected, I'm missing messages? How can I retrieve them? Same thing to send messages. So you can send messages via Relay, which is you just broadcast the message to any peer you're connected to. But again, if you're on a mobile phone, I don't have very good connectivity, then maybe you want to use light push, which is similar in the way that you send a message to one specific node, and this node confirms that they have received a message. And this node, most likely will be a server running somewhere, so that this one can then broadcast your message over Relay. So again, if you want to ensure that message is sent, and maybe you are on a mobile phone and you have not connected to a lot of peers, and connectivity is bad, so you use light push. And if the DApp is maybe running on the browser on a laptop, then you have good connectivity, connected to 10 peers, then you don't need to use light push and you just use Relay. So having this modular, Waku is built in a modular manner, which really allows you to have a solution for any kind of use case or any kind of situation. We have a couple of code examples. So we have a chat room. So it's actually, there's a link at the end. You can actually use it today if you want. So it's just like a nice little web app that shows you how you can use Waku to do chat messages. And we also have SDM for Ethereum Direct Message, which is a very simple, naive protocol to do end-to-end encryption, end-to-end encrypted direct messages. So you can use someone's Ethereum address to send them a message in an encrypted manner using SDM. And again, I have a showcase web app available for that. So it's very basic, and it's just about showing developers how they can do things like that, and then build their own dApps and then add their own features. And we also have all the code is documented, and we have quite an extensive documentation on the API available today. So as I mentioned, I only started with Status in March this year, so there's still a lot of more to do for me in the DappConnect project. So for now, it's just me. Actually, I'm hiring. So if you're a developer and you're keen, just let me know. I'm trying to have 2 more devs at the end of the year. So my next focus would be on having a website, which is being built at the moment, so that we can have more tutorials to explain how to use DappConnect and explaining more use cases. We go into use case after. I think what's important to understand is that Waku can really enable a lot of different use cases, and people may not realize that. So that's why I want to spend a lot of time ensuring that we can, list all possibilities, all possible use cases with DappConnect and Waku. I'm going to focus on more code examples. For example, Stationaries is a very interesting example where we can use Waku. At the moment, JS Waku is not yet used in production, but in Status, there is a couple of dApps that are being built on JS Waku. So I need to ensure that a few bugs are being fixed. And I also want to do more Web3 integration. So like integration with the wallet. For example, if you want your messages to be signed, be able to use the Web3 API to sign your messages. Everything is open source. I'm trying to work in a very open manner. So feel free to check the project board to know what are the next priorities and what we've been working on. So in terms of use case, why would you want to use DappConnect? So anything off-chain. So anything that that is off-chain in the way that when you go off-chain, it means that instead of doing everything on the Ethereum blockchain, you are taking communication out of the blockchain directly from peer-to-peer, and maybe gathering data, changing states and things like that. And then at some point, you may decide to use the blockchain or not. So any kind of communication. So anytime you want to go off-chain, you could use Waku to handle this communication, so that for your project, you don't have to worry about infrastructure and things like that. But again, it doesn't need to be always related to blockchain. So you could use Waku for things which are not blockchain related at all, and where you just need to have some communication. So one use case I already mentioned quite heavily is a chat app use case. So the status chat app uses Waku v1 and is being migrated to Waku v2. And this allows you to have some private groups, private in the way that they are end-to-end encrypted, public groups, and private peer-to-peer messages. Let's jump directly to Ethereum scalability solution. So that's a use case I'm very excited about. Whether you look at state channels where two or several peers will lock some assets on the blockchain, and then we exchange messages to that describe a change of state, and then after 10, 100,000 messages, finally decide to go to the blockchain. So being able to save 1,000 of communication to blockchain by having off-chain communication. This case could use Waku instead of having to build your state channel and start to decide, okay, how do I do this peer-to-peer communication? You could just use Waku directly. And that's, I think, is very interesting case. And as I mentioned, I will build some code example shortly for that. Same thing for rollups. So in the case of a rollup, whether it's optimistic or ZK rollup, today, so the participants, once the rollup is started and participants join the rollup, they have to send their rollup transactions to an aggregator, and then the aggregator can take this transaction together and submit a rollup block, Merkle root usually, to the blockchain. So today, if we were to do that without Waku, most likely then the aggregator will have to run a server with a public IP and some port open so that participant can contact the aggregator and send him or her these transactions, which of course can lead to censorship and any problem like that. Instead, you could use Waku and have the transaction, the rollup transaction sent over Waku, and having the aggregator listening for this transaction and then gathering them and putting them on the blockchain. I still need to do more research on this specific topic, and I'd be very interesting to see if such a model would then allow a fairer competition between aggregators. So I don't know yet, can you have several aggregators for rollup? I think it'd be interesting to see that and see if aggregators could compete gathering these transactions and being the ones who mean the block. So it's very early on at this stage. I haven't done enough research on that, but definitely in terms of communication and being able to pass the rollup transaction to the aggregator, I think it'd be very interesting to use Waku. So the aggregator doesn't have to disclose, any kind of IP address or DNS, or doesn't take the risk of being blocked by, by a provider or anything like that. Voting. So voting, we have a couple of voting features. So currently, Status is building the Status community directory creation DApp. So it's basically just a DApp where you can vote for, so communities being a group chat, and you can vote on chain for your community so that it appears in the directory. And so the idea is that when you join the DApp, you can see communities in the directory and join them, or you can create your own community and have people vote for it to be included in the directory. So we're using Waku for two reasons. So to vote, to have the community in the directory or out of the directory, anyone with a status token can vote. So instead of having everyone spend gas voting on the voting for the community, what we have is that the community owner will start the vote on the blockchain, and then participants can just send their vote over the Waku network. And the actors that are most interested in having the vote, happening can then gather all these votes and pay the gas. So as a community owner, I can create the vote. I will gather all the votes for my community and then submit them to blockchain, and I'm the one paying the gas. And then if I'm someone who is really against this community being voted in, then I can gather the vote as well myself. I'm sure that the no vote are being submitted to blockchain. But if I'm someone that is just, I'm just using the community and I think it's a cool idea, I want it in the directory, but I'm not that incentivized to pay for the gas, and I can just send my vote over Waku for free. That's for voting. So voting meaning that the result is in the blockchain. For polling, so what I call polling is just when the result is not submitted anywhere. We have an interesting use case here as well. So it's a featured community. So having like 5 features community per week, showing up in the app. Here's the feature community of the week, and that is done entirely through Waku. So you can vote for a community over Waku, and then each DApp, so each mobile phone, each user will just collect the votes from the Waku network, and then we calculate, this is the most voted community this week, and just display them. And that's one way to have a decentralized communication layer and decentralized polling. And because it's just about showing a community for a week, you don't need to go to the blockchain, you don't need to pay gas in there. And so this one are being worked on, and so that's a DApp which will be using Waku, GS Waku very shortly. And yeah, so really, I hope I'm making it clear. So really, any kind of communication can be decentralized using DappConnect, and that is again without the burden of solving the hard problem of decentralized communication, of spam protection, of efficiency and scalability, and things like that. So other use cases I'm looking into are, for example, NFT auctions. So at the moment, I'm aware that most NFT platform where you can auction an NFT usually are custodial platforms. So they have the rights, they own your NFT, and you can put it on sale. And this is an off-chain solution in the way that when you put it on sale and people can bid on it, it's all happening on this centralized platform, so it's off-chain, but it comes with a risk of custodial solutions. Like if there is a hack, if there is the company is going down, anything like that. With Waku, you could move your NFT auction to a decentralized manner. The idea would be, for example, as an NFT owner, you start the auction on the blockchain, and then people bid over Waku. And at some point, you take the highest bidder message, and using that, you can put it in the blockchain and have the transfer done. So again, more research is needed here, but I think it's a very interesting use case on how you can decentralize some current, some projects that we have today very centralized. DappConnect 2.0 uses Waku. So they don't use GS Waku yet, but they use a new Waku node to be able to decentralize communications. So today, when you use DappConnect, which allows you to easily connect a DApp and your wallet, you have to communicate with DappConnect servers, which is a risk because centralized servers, it is a risk because it could be IP blocked or anything like that. So instead, now they use, so for DappConnect 2, they use Waku, meaning that to do this communication, you do it over the Waku network, and their server can just listen on the Waku network without exposing themselves to any kind of attack. And more. So there's many use cases, and part of the website we are building is to really list all the use cases that you can do with Waku. And the idea is really in all these situations, you don't have to worry about how do I protect against spam, how do I ensure that my users with a mobile phone receive all the messages, because Waku helps you with that. Yeah, so let's look at the code. So we're going to look at GS Waku code, which is what you would use as a DApp developer. So very easy to create a Waku node in your DApp, just waku.create, straightforward. I'm trying to apply very good defaults. So the idea is that, minimum parameters, minimum options, just out of the box, it works. And then if you want to fine tune things, then you can. So to listen for messages, so just going to talk a bit more about the content topic concept. so the idea is that on the Waku network, all messages are being transferred on the Waku network. Now, as your DApp, or I'm a user, I'm using a DApp, I don't care about messages that are not for my DApp, all right? So what we use is that we filter messages by content topic. So as a DApp developer, you decide what content topic you want your DApp to use, and in this format. And if maybe there is several features, maybe you have group messaging, and you have direct messages, so you may have different features, so you may use different content topic. And then your DApp to receive messages, then you can do waku.relay, so using the relay protocol, and you add an observer that and you pass a callback function with message, and then you can process the message. And when you do the add observer, you specify what content topic you are listening to, so that you only process messages that are relevant to your DApp. So that receive messages, 3 lines of code. To send messages, so it's a bit more. So if you just look at the first part, so Waku message is just a message over Waku. When you create a Waku message, you specify the content topic to ensure that it's only received by other instance of your DApp. And then you can either use, so you can see waku.relay.send. So using relay, that's a peer-to-peer. So you can use relay to send a message sent to neighbors and can then broadcast it to their neighbors. Or if maybe you have some connectivity issues, you can use light push, which will find a light push node. So usually it will be a name Waku node, like a server node, like a node that is running a bit more permanently and not on a mobile phone. And you can give them a message, and they can reply back to say, yes, I've received a message. So this obviously has some privacy drawbacks. But again, as a DApp developer, you can decide what is the best for your DApp. And you have the choice. Then to retrieve messages. So we talk about receiving messages in a peer-to-peer manner on the Gossip network, which is a relay. If I lose connectivity, so I'm connected to 0 peers because maybe the phone just I just lost connectivity, and now you're resuming connectivity, and you see I'm reconnected to peers now. Then to retrieve the missing messages, you can use the Waku store protocol. And again, here it's really very easy in the way that you just pass your content topic to the query, and JS Waku will look for a store node for you and select one for you, and then return the messages. So the idea is really to have something which is very easy to use out of the box. Okay, and as I mentioned as well, so if you want to have clear messages, that's fine. If you need to have encrypted messages or you need to sign messages, again, JS Waku is providing a very easy interface for that. So you can see from here, there is a helper here to generate a private key. However, I'm also keen to make it easier to use Web3 keys as well. So I'm working on that. But the idea is that when you create a Waku message, so payload is just your data, what you want to send across, and you can just pass the encryption key or the private key to use to sign, and Waku will handle the encryption for you and package it in a Waku message and send it over the network. I see a little question. No, so yes, that's so I have a question from Peter. I'll jump on that. So yeah, so in Whisper, indeed, one of the issues that we had. So the question from Peter is: are message routed, or do they flow through the network like Whisper? So that's the thing, that Whisper was flooding the network, which is one of the scalability issues that Status encountered when creating the mobile app on Whisper. So messages. So the relay protocol is based on the Gossip sub protocol of P2P. So the messages are being routed and in Gossip sub manner. So in the way that it maintains the number of neighbors that is not too big, as Gossip sub do. What's interesting as well is that at the moment we use one pub sub topic, if you're familiar with that, for all messages. But the idea is that we are ready, or at least we have written protocol in a way that will be very easy at some point to maybe implement some shards or things like that to help with the protocol. In terms of, for example, when you do a store query, you only query for your content topic so that you only receive messages which are routed to you. And we are going to extend the store, we are extending the store query to be able to also provide a timestamp so you can just receive messages, get messages within a time range. So in terms of public keys communicated, so Waku doesn't really handle this part, so it's up to you. So so I created the SDM protocol, which is very a naive way of doing that. And you can dig a bit more into that. But the idea is that users send a message where they sign an encryption public key with their Ethereum account to the network. And so that when you want to send a message to someone with this address, you can look for the message with their public key. And so we're using Waku for that. That's a very naive protocol. I'm sure there is better ways to do it. The idea was to just demonstrate how you can do things with that. And finally, Lecky was asking questions. So yes, at the moment for the web, we are using WebSocket. So, and that's one of the things as well to be aware of is that, in a web browser, you don't have access to TCP stack. So we are using WebSocket in this case, and that's what's available for JS Waku. All right. A lot of questions. And then again, so let's say you are using, you are encrypting your messages. So to decrypt messages, what you do is just pass the decryption key to Waku relay. And then you can receive message as usual. So again, a very easy way for you to have end-to-end encryption is just passing the key to Waku relay. And then when you receive a message, it will try to decrypt it. And same thing when you try to do a store query, you can pass your decryption keys to JS Waku, who then will try to decrypt messages it received from the store query. So we're trying to have a very simple usable API. Okay, yes, I'm done basically. So thank you very much for your time. So here are some links. So the slides are available online. I will put a newer version in the Google Drive. JS Waku, so at the moment, as I say, we are working on the website, so I don't have a nice website to showcase just yet, but we have the JS Waku repository, which contains the library and contains a lot of documentation. Feel free you can directly jump to these links right now. This is the web chat I was talking about, which is a little web app to have there's one room, and you can just chat in there, and it uses Waku in the background. And SDM is the one for end-to-end encrypted messages. So this one is connects to your to MetaMask, to your wallet, to allow you to send a message to someone just knowing their Ethereum address. It is opt-in, so you have to send your public key first over the network, and then someone can use that to send you encrypted messages. Website is coming, and so the spec. So the Waku spec are open source. Anyone can come in and create a new spec or command. So it's really trying to it's really handled in an open source manner. Okay, and sorry, on the last slide it's a bit cut. Let me just fix that. Yeah, so if you have any questions, please come in while I fix the last slides for the next talks.
Yeah. Well, thank you for your talk. Ah, there we go. So yeah, thank you for your talk. So I already had my questions in the chat. Actually, here is another question. So proof of work was being used in Whisper as a way of rate limiting and anti-spam. So how have you addressed that in Waku?
So yeah, so first, I think it's important to mention that the idea is to have this protocol very modular. So I expect at the end to have several ways to do spam protection with several different protocols, and then it will be up to the developer to decide which is best for their application. At the moment, our researchers are working on so it's called RLN, which is a rate limiting nullifier protocol. The way it works is it's very interesting. So you have a smart contract. So one smart contract is being deployed, and if you want to participate to the network, you are going to lock some funds in the smart contract. Then when you send a message over the network, you have to basically provide a shared Shamir secret with your message. And this secret is only valid for one epoch, which is 1 second. So if you send a message, it has to have the secret. And when someone receives a message, it verifies that it is valid within the 1 second, within the given epoch. Now, if you want to spam the network and send a second message, if you send a second message and it's not valid for this epoch, then it will be, the recipient will drop the message because you say, well, this secret is not valid for this epoch, so I'm not going to broadcast it. I'm not going to forward it. If you are using the same secret, then say, oh, we already use this secret, so I'm not going to forward it. So, and if you decide to use a different share, then that's enough share to steal your money from the smart contract. So you have a situation where, and that's how. So that's one of the situation. And what's interesting as well is because it uses zero knowledge proof. There is no someone looking at smart contract cannot guess. So like the identity, the Ethereum identity on smart contract is not related to the Ethereum identity to the Waku identity on the network. So because you use zero knowledge proof, when you receive a message, you know that this proof is covered in the contract, but you don't know which Ethereum account added, log the account. So you have this privacy feature. So yes, that's that's the current spam protection that is being worked on.
Okay. Oh, sounds interesting. Yeah. Are there other questions for Frank? All right. Well, I'll post the recording maybe later today, maybe tomorrow, and onto YouTube, and people can post questions as comments on the video. Yeah.
Yeah, absolutely. And I think my I go, sorry. I never go to the last slide when I train on this presentation. Let me just, because I have some links. So I am on Twitter, and we have a Discord channel as well. So if anyone is interested, they can just ask me questions on Twitter. Have a look at the GitHub repo, open issues if needed. And okay, no, it's not happening. All right. And
yeah, sounds great.
There you go. On Twitter, and we have also a Discord server where we discuss both the protocol and both DappConnect and use cases. Yeah, so feel free to join the discussion at any point.
For sure. All right. Well, thank you again, Frank, for giving a great talk today. And yep, talk to everyone in 2 weeks' time when we have our next talk, which will be on ZK Starks. All right.
Thank you for having me.
Not a problem at all. All right. Bye-bye.